That sounds great. We'll do. Well, good evening, everybody, and thank you for being here. I know that unfortunately my broadcasting setup isn't allowing me to do picture-in-picture tonight, but I enjoy seeing all of your faces there. So thank you for coming out. I'm very excited to present to this group. I was mentioning to Cynthia prior to getting started here that software automation has been a big part of what I've done over the past 15 years in leading teams to reduce their feedback loops, help their customers get to market better, make sure that we can move work along rapidly without having to worry about defects and breakages quite so much. And I'm really looking forward to talking about this concept tonight because I think functional testing is one of the ways that folks can get into testing in general and can start to understand the value of testing and test automation. And so one of the things I'm going to demonstrate tonight is we'll talk a little bit about functional testing as a concept, and then we'll talk about SpecFlow as a tool for doing that. Now, SpecFlow is a tool within the .NET ecosystem. There are many other tools. We'll talk about some other alternatives as we go through the presentation. But very excited to be here with you all tonight, and I appreciate you coming out on an evening. I know many of you may have been home already due to the remote work conditions, but very happy to be here. So I am with a company called Captec Consulting, and so we are located nationally. We're a national organization. We're working remotely right now. I am based out of our Reston office in Virginia. So we are a consulting firm that works in the commercial sector and the state government sector, doing everything from cutting edge mobile development and AI, ML, to systems integration work. My current project is a systems integration between a custom CMS and some gnarly back-end logic. And so we do that kind of plumbing work as well. And certainly automation is going to factor into all of that. We do web development work, and similarly to the announcements earlier, we're hiring generally for many positions. So feel free to reach out to me if you're interested in us or you'd like to learn more about our culture or our work. And I'm certainly happy to talk to you more about that. But that's not what tonight is about. I also like to put a plug in. I know this is not necessarily a .NET oriented group, but there's a great organization out there called the .NET Foundation, and that works to support open source in the .NET ecosystem. A lot of the tooling and technology that I'll be talking about tonight, SpecFlow happens to be an open source product that is for free. And so .NET supports many free open source projects in the ecosystem, or the .NET Foundation rather. And so I like to give a shout out to them. Membership is you're able to join. It's a small amount of dues and an application, but you get access to a great community of folks who are working to make to really support open source software. So if you're ever interested in that kind of thing, I know this might not be the exact venue, but feel free to talk to me about that as well. I should have mentioned this before, but hi, I'm Sean. I've got my contact information here, but don't worry about that. I'll have that up at the end of the process as well. So let's jump into this today. We're going to talk a bit about why functional testing and test automation in general matters. We'll talk a little bit about specification by example and what that means and how that helped us evolve our testing practices. We'll talk about functional / acceptance testing. It's called many different things, called by many different names. So we'll discuss the concept of functional or acceptance testing. We'll talk a little bit about the Gherkin syntax and what that is and what the components of it are and why they help us express our specifications by example. We'll kind of recap some of the benefits, and then I'll save the remainder of the talk to some demos of a hands-on of a tool called Spec Flow, where we will actually open an IDE and we'll wire up the testing framework with Spec Flow, and we'll write a little bit of tests, and hopefully it won't be too daunting. It will be in C#, but the concepts will hopefully be pretty straightforward, and we're not going to go deep diving into any complicated code tonight. And that's one thing I wanted to mention actually, is that we won't be diving into a browser automation in this test. I want to show, because I think so often we equate functional testing with browser-based testing and Selenium. And so I want to show you, I'll show you sort of how you can set yourself up to do that. I'm certainly happy to talk to anybody after this talk about how you like to approach browser-based testing. I'm a big fan of it in many ways, of browser automation and testing, but I didn't want to go too deep into the technical and show a few hundred lines of code of setup to make everything work tonight. And so we're going to keep the examples fairly straightforward, a little simpler tonight. So why does testing automation matter? Why does functional testing matter? And one of my favorite comics by XKCD is my motto is move fast and break things. And you can see underneath jobs that you've been fired from, FedEx driver, crane operator. And to me, this really speaks to why automated testing is important, because we in many lines of business don't have the luxury of moving fast and breaking things. That's not, we need to move fast without breaking things. Breaking things is a luxury that most development teams and most delivery teams just don't have. We're not trying to we don't say, oh, it's great. We know that things failed, but we moved quickly, so it's all good. That's not going to lead to a great result from our stakeholders or from our end users and our customers. And so we want to talk about some of the problems that can happen in thinking about requirements and thinking about details and specifications. So one of the things that can happen right in the course of specifications, and I'm sure being folks who are familiar with QA and who work with development teams, I'm sure you've experienced confusion before over what a requirement actually meant, right? Or how did you define login? Or how did you define a certain term? And the confusion and the implicit definitions that can happen when you're working through specifications or when you're trying to design those things together as a team. And oftentimes this can result in work coming back or not being quite understood from the outset and causing churn in your development flow and your delivery flow for your team. So one of the things that functional testing and specification by example are going to help us do is remove some of that confusion. And we'll talk about that in a little bit. Trust is a big issue with, or not issue, but trust can be a big challenge sometimes in client environments. We want to build up the trust of our stakeholders and our users. And if something is breaking or you're having regressions on a regular basis, then what's going to happen is that trust is going to erode. And sooner or later, you're going to have developers start to say, oh, our coders start to say, oh, everyone's really nervous to touch that piece of code, or we're not quite sure that we understand how that works. Or you'll have clients or stakeholders start to say, every time we touch this, it breaks. Why is that the case, right? And we don't want that trust level to go down too much, because what that's going to happen is it's going to erode the confidence in our overall delivery pipeline and our delivery system. And when that happens, you start to introduce gaps into the process and slow down into the process. When what we really want is small feedback loops and a highly collaborative nature of software development between coders, QA, business analysts, client stakeholders, right? Making sure that everyone is collaborating on small feedback loops. And if you don't have that trust there, then there's a lot of double checks and a lot of really long user acceptance testing periods of manual testing, and it starts to delay and erode our ability to actually adapt and change and produce meaningful value for the business. So trust is a huge factor in automation, or rather automation is a huge factor in trust. And so we'll talk about how we can start to build that up. Now, I don't know if you've ever encountered this. I imagine some of you certainly have. I call this feature fighting. There may be a more topical name for it, but when you build something as a development team and then it breaks later because you are actually implementing a requirement from someone else in the business, and those two requirements happen to conflict with each other. In this case, those things can be difficult to find unless you happen to be doing manual regression testing, but certainly automated unit testing isn't necessarily going to catch those issues. But automated functional testing is going to go a long way towards helping you ensure that one feature request doesn't break another feature request. And so I call this feature fighting. One of my other favorite challenges in the world of software development and testing is the idea of, so there's always that sort of negotiation over what does done mean, right? When are we done? And with vague specifications or high level specifications and not a highly collaborative environment where everyone's on the same page sort of naturally, you can start to have confusion over when is something done, what does done mean? Your team finishes some work, but then someone says, well, what about this scenario? And you hadn't thought about that scenario or talked about it. And so that can sometimes be a challenge in a delivery environment. And so functional testing automated functional testing and automated acceptance testing can help us, stop that sort of negotiation, stop that sort of back and forth that happens, because it enables things to be much more explicit upfront. And so we don't want these things to be happening. We don't want low trust. We don't want the back and forth and the churn. We want the highly collaborative, small feedback loop, fast delivery, ability to adapt, right? And so here's where we enter test automation, right? Test automation is your team's safety harness. right? You may have manual test cases, and that's phenomenal, and hopefully they're clearly expressed, but test automation and the amount of test cases that you have serve as a safety harness for your team. They allow you to go faster and without feeling unsafe. So, right, there's that move fast and break things model again. We are able to, with test automation, move fast and avoid breaking things, which over time leads to a sense of confidence and allows you to feel like you can adapt a little bit more as a team because you have a safety net behind you. And one of the ways, we started doing this early on with unit testing and automated testing and test-driven development and some techniques along those lines. And those are usually done at the unit level, right? Meaning one particular class, very low level in the code, completely isolated from the rest of the code. And so these tests tend to be very technical in nature. And they tend to, really, if you're not a coder, it can be difficult to understand them. If you are a coder, it can be difficult to explain them. So there's a bit of a communication gap there around the tests. And so what we found, what entered the picture here is there's a great book. This is one of my favorite books along the way about this topic, is the idea of specification by example, or business-driven development as well, or BDD tests, where we try to streamline the language of the test and we try to make it a little more human understandable rather than looking like machine code. And so the BDD nature of the test, maybe we're making some variables clearer, or we're making the names of our tests read a little bit more like human sentences. But the idea of specification by example sort of takes that to the next level. What we say is, with specification by example, is that you have we can express the language or the intent of the system in human understandable terms and human readable sentences. And rather than saying the system shall, or having a vague requirement, we provide one or usually several examples that help highlight what that specification might be. And there's a big advantage in that, which is to say, if you've ever been confused talking to another human being, one of the things you might often say is, hey, give me an example. What do you mean? What do you mean by that? And so specification by example takes that and moves it into your automated testing and your automated, your testing nomenclature. And by using certain formats that we're going to talk about in a little bit, called the Gherkin syntax, you're able to make that language a bit more accessible to people in your group, and you're able to sort of collaborate a little more closely on that. So let's talk for a second about functional and acceptance tests and sort of where they are in the scheme of tests. So you may be familiar with this box before. I think this is an old, Brian Merrick, I think, invented this some time ago. But there's sort of the idea of a four. By the way, if you ever want to get famous, invent a box that has 4 quadrants and put some things in it, and you'll take off like a rocket ship. But Brian Merrick, I think, had come up with this. And certainly that's where I saw it. And there are there are 2 different axes for your automated tests. So on one hand here, we have up top, we have our business facing tests, right? And this is at the top of our quadrant here. What we mean by that is these are tests that are going to be human understandable, right? Or the human beings that aren't coders are going to be able to interact with and understand. And on the other end of that spectrum, it would then be technology facing tests. These are tests that are going to have they're really going to be, you're going to have to be a coder to understand these tests. You're going to have some understanding of the coding language that things are written in order to understand them. And the other set of axes are here for the spectrum of, there are tests that support programming, which is to say, they say, hey, this thing works as I, the developer, think it should work, right? I am proving that the code is doing what I, the developer, think it should be doing, or I, the coder, think it should be doing. On the other end of that spectrum are tests that critique the product, right? Are you building the right thing? Are you building, rather than just building the thing right, are you ensuring that from a user's perspective, the tests the product is going to do what they expect it to do? And so functional and acceptance tests tend to live up at this top left quadrant, which is to say they are business facing. They aim to be human understandable. They shouldn't have to be a coder in order to read them. And they should support, generally speaking, the programming. They're proving that you are writing the code of the application the way that the requirements or the stakeholders need them to be written. Now, in some cases, sort of, functional acceptance tests may also live a little bit over here on this top right quadrant, which is to say they critique the product. They're saying they're kind of looking more outside in, and they're saying, are you building the right thing? Are you building the application as you're intended? So they kind of bounce across both, in my opinion, but they tend to live up at the top left quadrant here. And these tests, one thing that's important to note about them is that in a traditional, we speak about unit testing as coders. Oftentimes what we mean is coding, testing things in isolation. So you're not testing multiple real things wired up together. You're not testing with a real database. You're not testing with a real network connection, right? You're sort of isolating a piece of code and writing a very small test around that piece of code. Functional and acceptance tests by their nature kind of require the whole stack of stuff to be integrated, because you're looking at these items from the perspective of outside-in testing. So you want to make sure that you have these wired up for real results. And that's important because sometimes we miss the difference between isolated testing and integrated testing. And integrated testing is important because I like to have a few examples of this, because you may have a hand dryer that works correctly and the wastebasket works correctly in isolation, right? But as soon as you put them together, things don't quite go as you might expect. And so integration testing is pretty important. Similarly, we've got integration testing there, right? The doorknob, the latch worked, the hole was drilled, it worked correctly, except that we forgot to integrate them appropriately, and the door will just simply slide away. One of my favorite ones here is the faucet and the sink, clearly working together in isolation, but working together integrated, not quite the result that we are expecting. Another one of my favorite ones, not an exit on the door versus an exit sign pointing to the door. So it's important that we integrate things together. We test these things overall and holistically. So how do we express functional testing or acceptance testing in the language of the business, and what is this Gherkin syntax that we keep hearing about, and how Gherkin syntax, it can be thought of as the language of specification by example. It's a way that we as human beings can sort of adopt a standard to help talk about some of the examples that inform our specifications. And so what I mean by that is that typically a Gherkin syntax has three major components. There's given statements, there are when statements, and there are then statements. And so let's show an example of this now. So an old specification might be something along the lines of the system or a system shall allow login access. Right? It doesn't tell us a whole lot. There's a whole lot of room for misinterpretation or high level stuff. You probably have to have many conversations. It might not be clear. Different people have different ideas. But a little bit more clear of an example might be something like, given I am on the home page and I have clicked the login button, when I enter a valid username and I enter a valid password and I log in, then I should be redirected to my profile page. Right, so let's think about what this simple syntax has actually told us in this demonstration. So step one, given I am on the home page, well, I know that I have to have some sort of setup and running. I have to be on a home page. I know my starting state. It's also written in the first person. So we may not know exactly from this example who the I is, but we are written in the first person because there is an actor of some kind and they are taking actions. So given I am on the home page, if I was a manual tester, I would fire up my browser and go to the home page in my environment. Okay? And I have clicked the login button. So what we're doing with this is, we're saying, hey, you should click the login button, but we're also setting up the universe of the test, for example. So what we're saying here is, if we click the login button, that means that we have to have a login button available, right? And it also means that we're not entering a username and password until we've clicked the login button. So if there's no login button there, if you haven't clicked it, the later steps don't necessarily make sense, right? And we see the importance of the given statement in a lot of cases around data setup. So if we're going to, return a user from a database, we might need to say, hey, given that this user exists, right? And then then that given statement kind of gives us some clues as to how we might set up the automation for our example. But we have our when statement next, which is the actions that a user is taking. And I should mention that there's various flavors and opinions on how to factor these and how to structure them. And certainly this one could probably be improved a little bit. It's a basic example. But what we're saying here is that, you know, when I enter a valid username, so I could think of, okay, maybe I've got a list of valid usernames, or I'm taking those examples, and I enter a valid password, and maybe I'm typing text into a text box, all right, and I log in, then I should be redirected to my profile page. So we'll see actually here that this is something that we can say, hey, that's a pass or a fail, right? Either this did happen or it did not happen, and it's pretty clear what should happen. One of the nice things about this is that if I brought this, we were talking about a login system, and I brought this specification, this example, back to the client, and I said, hey, here's the example, right? Well, this is how we're thinking login is going to work. And they said, oh, well, no, we want people to sign in with Google, right? Oh, that's really important to know. And we may have had two different ideas about what login meant until we actually went through an example of how that's working. So what we've done by sort of collaborating on these specifications is opened up the space for conversation to talk about some of the differences in how those specifications might manifest themselves for ourselves, and how we might actually get to a more specific detail on how these things are going to be executed. So another example that I like to give is the idea of a shopping basket or a shopping cart, right? So we can say, you're given my shopping basket contains one copy of Harry Potter. Note the very specific language here. We're using Harry Potter, a real book. I didn't pick a specific Harry Potter, but we're using one copy of Harry Potter, and we're using an actual example. This is helpful rather than just saying a book, because when it helps set up the actual way the human brains think about these things. And so you have the given, which sort of maps to the arrange or setting up the initial state of the system. And then you have the action, which is part of the when steps. When I add the book Harry Potter to my shopping basket, right, which already contains one copy, then my shopping basket should contain two copies of Harry Potter. That then statement is the assertion. So in automated testing, we often call these steps arrange, act, and assert. So what we wanted to show with this is that your given, when, then statements map quite well to the idea of arranging the universe of a test, performing a step, and then asserting what the result of that step should be. And so the nice thing about this example too, we look at the then statement, should contain two copies of Harry Potter. And one of the things I think of when I look at the statement is, does that mean it should have two line items that each say Harry Potter, or does that mean it should say Harry Potter with a quantity of two next to it, right? And maybe maybe the stakeholders hadn't thought about that yet. And that's a great opportunity for someone in QA to interject and really add some great value in bringing that conversation to the forefront. Or maybe that it just wasn't quite explicit enough, and then you could modify this example to include that. Maybe your team in general agrees that, okay, well, whatever way is most efficient for the development team to implement, right? Maybe you don't build out the quantity functionality yet, and so just adding two line items, that's fine. This is still expressing what, the overall functionality of the system, and so it doesn't matter to me, the stakeholder, do it whatever way is most efficient. But either way, having that conversation provides a lot of value from the perspective of an overall development group. So what are the benefits of specification by example and of automated functional testing? I love this graphic to describe sort of how the ecosystem works here, right? So we have tests on the left-hand side, which consist of examples. The examples are what describe your requirements, right? You don't have requirement statements, you have examples, and those sort of roll up to help give you an understanding of what the requirement is. And then you have tests, and those tests verify the fulfillment of the requirements because they consist of the examples. So what we can do with something like this, is we can take our, say we have say we've got a user story, and that says, provides a piece of value, as a book shopper, I want to be able to purchase, as a Harry Potter fan, I want to be able to purchase multiple copies of Harry Potter so I can give them to my friends, something like that, right? So maybe we've got the acceptance criteria that says, hey, can add multiple copies of a book to the cart. And then we so we sort of have that one bullet point of acceptance criteria. We can express the example, that Gherkin syntax, and then we can actually turn that Gherkin syntax, which we'll show today, into automated test language. We can actually map that human readable sentence into an automated test that will execute. And so what we can do there is we sort of we write that automated acceptance test. It's going to fail because we haven't written the code to help it yet, or to implement it yet. Then we're going to build up the unit tests underneath and the integration tests on top of those until we get to a point where all of those tests are passing, and we've built up to the point where now the requirement itself passes and that automated acceptance test passes. And then we can wash, rinse, repeat. Right, so we can sort of do this and churn through these stories. And so what the other benefit is that we then get consensus, right? Because we understand that these examples are the things that we'll be automating. These are the things that we'll be testing in our stories. We have this sort of agreement on the set of examples. If someone says, well, I don't understand those examples, or what about this scenario, or what about that scenario, that's fantastic, because you can then add to your list of examples and discuss them, and you arrive at that consensus. So those list of examples are sort of representing the working consensus of your development and delivery teams. So as a result of that, a lot of the process, which is, of course, lots of folks love this term, shift to the left, but in your development process, if you have these list of examples and you've discussed the examples of the requirements ahead of time, and you know that you'll be automating those examples to verify that your code is fulfilled, or is fulfilling the requirement, then you actually have a great start on what that requirement is, and it shifts a lot of work to earlier in the process. Previously, I don't know if you've ever been a part of an environment where, okay, the developers or the coders do some work, then the QA person tests the work, right? And then they do their sort of exploratory testing. They may be testing an example or a scenario that no one else had thought of. You give that response back to the development team. They say, hey, this isn't a part of the requirement. There's now a conversation that has to happen. Or, right, you as QA you say, hey, it looks good to me. You pass it on to a stakeholder for some sort of user or acceptance testing manually, and they come up with a brand new scenario, or they think, it should also do X, Y, and Z. And it's very difficult to keep control of the workflow or to keep things moving smoothly when you have sort of that churn and that back and forth. So one of the things that specification by example does is it gets everyone on the same page earlier on, because anyone in QA, the coders, the stakeholders, the analysts are collaborating on these examples, and you already have the testing plan up front. So it shouldn't be a surprise to anybody around what is being tested for this requirement or what it's expected to do. And so as a result, a lot of that work is shifted to the left earlier in the process before that work is ever brought into your development process. And that has the benefit of helping things move through the process much more smoothly. So that leads to smoother sign-off. If you are in an environment where users are or stakeholders or business stakeholders are signing off on your requirements or signing off on work that you're doing, being able to say, hey, well, we all agreed on these examples up front, and here's the automation where we prove that all of those examples are doing what they say they should do, then usually sign off is much easier to achieve, because the stakeholder is able to have that trust, right, that confidence in the overall development process. And one of my favorites is around Nist requirements. How many times have you gone back and forth because a user or a stakeholder has said, well, it should also do this, right? Or it's not working because it doesn't also do this other thing that we didn't discuss, right? And bugs being surfaced, requirements being surfaced as bugs during the user testing process. So one of the big benefits of specification by example and of functional testing is being able to say, that if there's a missed requirement, that's okay, because it's just additional piece of functionality that we learned. What is the missed requirement? Can we express that as a set of examples? And now we can either agree to implement that because, it looks like we all missed that requirement, so we can add that example and agree to incorporate those changes, or we can move that out to a later piece of work because we're able to understand what the examples are and where they came from. And so maybe it's not urgent to add it right now, and we can sort of document those examples for later, knowing that it should be fairly straightforward to test them because we already have tests in place. So that helps the Nist requirements as well. And I want to tell a story a little bit, just really quickly, about a way that this actually impacted a client that I was working on. And so I'll just, I'll stop screen sharing Elmo here for a second. But I wanted to talk briefly about the story that I had on a client project where we were actually working on a retirement benefits system that handled over $7.5 billion in assets. And as part of this retirement system, there was a calculation for who should receive benefits, right? Who's eligible, right? The eligibility engine. And so this engine was very big and very complex, and this was a mainframe modernization project where we were sort of being archaeologists and pulling requirements out of many years ago, and there were many business stakeholders that didn't always agree on the requirements. So over time, this engine, as you might imagine, became a bit of a mess. And so now came a requirement where the group, it became one of those pieces of code that no one quite wanted to touch. And whenever folks did, even though we had some automated tests, there were still regressions, and business stakeholders didn't have the same idea of what it should do. So it was always kind of a mess to work with. And along came the requirement that this system, now that it had been converted from a mainframe, needed to support an entirely new kind of retirement plan. Right, getting around this participation engine was no longer an option. Right, we were going to have to dig in, and we were going to have to make it make sense, and we were going to have to rewrite some of the code and make sure that it worked for these scenarios. So everyone, including business stakeholders who had experienced some of these regressions, were understandably nervous. And so what we did is we started trying to get on the same page about what is this system expected to do? What is it supposed to do? And so we started asking stakeholders, well, can you give me some examples of these scenarios? Right, and then we would listen to the users, and or the stakeholders. We would understand some of these scenarios, and then we would read it back to them in the Gherkin format. Right. Oh, so it sounds like what you're saying is, given that someone is of a certain age and they're in this demographic, then when they're a part of this certain retirement program, then when the participation engine fires, they're actually going to be in group A. Right. Oh yeah, and they say, yeah, okay, that makes sense. Now we've got one example. So we started from there. We started having these conversations. We gathered a few examples and we automated them. And we found a regression right away. And so the users, the stakeholders were pretty impressed with that. They said, oh, this is great that we found this issue already just by a few examples. We got more and more enthusiasm for participating in these question and answers and these example generation sessions. Similarly, we had one of those conflicts about requirements where stakeholder A said, no, the system should work this way. And stakeholder B said, no, it shouldn't. And so by surfacing and testing what the system actually did, we were able to, one, verify in human language that our stakeholders could understand what the system was doing. And those stakeholders were then able to kind of work it out amongst themselves why in that example the system was doing that particular thing. So we started sort of reverse engineering this code and working backwards. And over time, as we built up the confidence to cover this code, folks would say, well, what about this scenario? Well, we had already automated so many aspects of testing the system that adding another example was trivial at that point. And so we could start processing additional examples or additional input from our business stakeholders very quickly. And over time, the point that I want to make is that built up to 3,500 functional tests and examples. And afterwards, we were actually able to implement that the more complex engine in half the time than we estimated originally, because we were then able to go in, refactor the code, make it make sense, ensure that all these functional examples passed, and we were able to incorporate any nervous stakeholders understanding or example or wanting to make sure that a certain subsystem or a certain scenario was covered. We were able to accommodate that. And so that built up confidence in the system. And these tests, we had 3,500 of them, and they're functional tests, so they took about 2 hours to run, I guess, overall, because there's a lot of setup and processing involved for some of these results. But the idea there is that we were able to get feedback on this very complex piece of code in what they used to do for 6 months of user acceptance testing and exploratory testing. We were now able to have the confidence that we could proceed in a matter of hours rather than days or weeks. And so that's just an example of where this sort of testing actually helped, made my life easier, certainly, and helped the team that I was working with as well. So I'm going to go ahead and go back to the slides here. And so let's go ahead and talk about SpecFlow and what is SpecFlow as a tool. So SpecFlow is a tool in the .NET ecosystem. There are other tools in other ecosystems, such as the Cucumber tool in the Ruby ecosystem. I think Java also has a Cucumber tool. And so the idea of these tools is that they serve as a sort of glue between the human readable sentences of specification by example of the Gherkin syntax and the automated test steps that run as part of executing those tests. So we'll give an example here. So say, for example, I've got my human readable sentence on the left-hand side, and this is assuming a vending machine, I think. So SpecFlow is when you see AAT here, by the way, that's another term called automated acceptance test. Functional testing, acceptance testing, automated acceptance tests are sometimes abbreviated as AAT. Keep meaning to remove that abbreviation. But in this case, we can see that we have our Gherkin on the left-hand side. Given there is no money in the machine, right? So we're setting up the universe of that test and making sure that we start with 0. When I insert a coin, in this case, we are assuming a quarter, then the balance should be, and it's actually funny because the balance should be 0.25, but it's described incorrectly here as 0.025. So if you all caught that, then QA points for you. But the key here is that SpecFlow is actually mapping that given statement to the release change method, which is setting change to 0 and making sure that we're starting with 0 change in the machine. That when statement, SpecFlow is mapping that to code to insert a coin, which will increase the balance by 25 cents. And then the balance should be actually maps to an assertion that the balance should be equal to 25. The good news is that once you're writing these steps, most users, most stakeholders can refer to the Gherkin pieces and don't have to worry so much about the test code that's going on behind there. You can collaborate on that up front. But this might be a little bit esoteric or not really quite as accessible. So what I want to do now is I want to jump over to demo time. We'll see if it's a big fail, but we'll jump over to demo time. I'm going to pull up an application here, and we're going to go ahead and we're going to see if we can actually look at some specifications here in SpecFlow. I'm going to go ahead and zoom in a little bit. Cynthia, can I get a nod if that's an okay size on your screen? All right, great. So as I mentioned before, this is an example in .NET, so there is going to be some code. If there's a coding convention that is confusing, I just ask that you roll with it for a little bit and feel free to ask me afterwards. I'm happy to explain via email or in this session how that goes. So what I'd like to do first is we'll start from scratch, right? I've got an empty project here. I'm going to demonstrate adding SpecFlow. We're going to add the testing packages, and we're going to create an example test. Now, in this case, what we'll do is we'll create an example. We'll do the basics. We'll do a calculator or something like that. We'll test the add method. So first things first is I've got some tooling. In SpecFlow, one of the things that it adds is some tooling to give us some nice syntax highlighting and the ability to kind of see if things are off. And so SpecFlow is great tooling. And so I'm using Visual Studio currently to edit my code. SpecFlow is an extension that you can install for Visual Studio. So if we go to Manage Extensions, we should be able to see here. Hopefully I've installed it. Yep, here's SpecFlow for Visual Studio 19. So I've gone to online, I'd searched for SpecFlow, I had installed it. And what that allows me to do here in my from scratch project here is I'm actually going to right click on this. And I'm going to go to Manage NuGet Packages. So I've got to add some packages to enable me to make this work. So I have to add SpecFlow to my project as well. We have to choose which automated test framework SpecFlow is going to use behind the scenes. In this case, we'll use NUnit, 1, because it's the first thing that showed up in the list, and 2, because I work with the NUnit project, so why not? So to be clear on the difference between SpecFlow and NUnit, remember I mentioned that SpecFlow is sort of the glue holding those tests together. So SpecFlow, what SpecFlow is doing behind the scenes is it's reading that Gherkin syntax, that given statement. There's a little bit of tooling around it, and it's generating an NUnit test behind the scenes that will call the code that we tell it to call. And don't worry if that's a little confusing. We should be seeing an example of that shortly. So let's start off where I've got these libraries installed. I want to believe that that's all I need to do. I think those are the right packages here. I think I also want to install, actually. One second, I'm going to grab one more package here. Even though SpecFlow is running with NUnit, I think I have to install NUnit and the NUnit test adapter as well, right? Since we're going to be automating these tests using NUnit. Go ahead. Okay. And I think that should allow us to do it. So I'm going to write a basic test here just to make sure that things are going to work. And so let's go ahead and write our first feature. I'm going to right click on my project over here, and SpecFlow allows us to say add. I'm going to go to add new item. And I can actually, from my list of new things to add to my project, I can choose from the SpecFlow item to add a SpecFlow feature file. It's going to create a file off to my right-hand side here called SpecFlow feature1.feature. I'm going to call it basic math. Here, I'll rename it. And SpecFlow feature here, I'll rename it to basic math. So simple calculator for adding two numbers. This might be a user story where you might say, as a math learner, I want to ensure that I want to use a computer to add numbers so that I can avoid human error. Sure. So we've got some idea of a feature there or some value proposition. And I just want to demonstrate that what we're getting here so far is we can see we've got some highlighting here. We can see the title of the feature that I've given it. We can see the value proposition here. And now we have our first example underneath this. I'm going to remove this tagging because that's out of scope for what we're talking about today. But we have this idea of scenario. We have these scenarios add two numbers. We can see here there's some syntax, some examples that's been created for us. We see that it's in dark purple. Now, what that means is SpecFlow is actually giving us a hint here. This dark purple means we actually haven't implemented this yet. So let's go ahead and hit. Sorry, I usually have a key binding thing on the screen here. I just hit F12. Now, normally F12 will take you to where this is defined. But in this case, SpecFlow says, hey, no, there's no matching binding step found for this. Do you want to copy this helpful template to your clipboard? Why, yes, I do. That sounds lovely. I'm going to go ahead and rename this to basic. I'll rename my steps class to basic math steps. All right. And then here, I'm going to add something here called binding. And that is a SpecFlow nomenclature that it will look in this class for the steps that I have defined in my feature file. So let's copy and paste that and see what's going on here with this. So what we see here is that we have a given phrase here, and we see the first number is, and then there's a parameter. So firstly, if we go back to the basic math feature file, we can see it's no longer purple. It's now it's now white, showing that we have created it. And we can see the first number is 50. Now that's parameterized. It's not hard-coded. And so we can now reuse that test step to say the first number is 70 or the first number is 1 because we have parameterized it here. I'll go ahead and rename this from P0, which isn't very descriptive, to the first number. And so behind the scenes, we start off with this SpecFlow scenario context.pending, which means if I was to run this right now, it would say, hey, this step doesn't have anything. You should write something for it. So I'm going to go ahead and I'm going to create the idea of a calculator. So I'll create a public class real quick called calculator. And I'm going to create a public, in fact, we can probably do this even simpler. Let's go ahead and I'm going to say, I'm going to create a number in this class here. I'll call it first number. That's called an integer in C#. So it's going to start off defined as 0, but we'll go ahead and say, when they call the first number is this, we'll set first number equal to whatever is passed in. All right, so now I've got my first step. I've defined this first number in my test class here. Now, normally you might be creating a production class or instantiating something that is production code here. I'm just kind of hacking it in the test class itself. But normally you might say, hey, create a new calculator, or take the current instance of the calculator and set the first number to 1. But for the sake of expediency, I'm going to define that here. And similarly, for the second number, I'm going to go ahead and hit F12 and copy that helpful binding here. And then we see another given statement popped up. The second number is here. We'll rename this number. We'll create a second number variable here as well. And then we should, I'll go ahead and save this. At which point we see that the feature get uncommented. When the two numbers are added, we'll copy that as well. Now we see instead of a given format, we see a when format, when the two numbers are added, no parameters, because it's just that phrase here. And so here we'll have the idea of a result. And so we'll say when the two numbers are added, we'll say result equals first number plus second number. Okay, we're not doing anything there. We're just setting the result. Oh, we should set second number probably as well. So given that we have, given the first number is this and the second number is this, when the two numbers are added, then the result should be 120. We'll go ahead and copy that step as well here. Then the result should be, we have a parameterized example here as well. So we can see, okay, the result, or we'll say expected result. And then we'll use our testing framework now. Well, now we're going to use NUnit, and we'll say assert that expected result is equal to, or we actually should probably say that results, our actual value in this case, is equal to expected result. Right, so now we have our test feature is complete, and actually I have an automated test runner here called NCrunch, and it's just some more tooling that I absolutely love when working with automated tests. And we can see here that the scenario has actually been run behind the scenes and is passing now. If I change this to 121, we can see those tests are going to run again. I see a failure, and when I mouse over this, it's a little bit small to see, but if I was to pull up my NCrunch tests here, I'm just going to go ahead and show my test window here. We can see that's a little bit small, but we can see that, in fact, I'll paste it on the screen here. So we've got it in the window here. The output that I get is we can see it actually outputs the test step and it says done, the second step done, the third step done, and it shows the code that it called to make those steps happen in our automated tests. And it shows, hey, we expected it to be 121, but it was 120. And I can see the code that, the code point at which that returned as well. So I can say, oops, you know what, I typoed that, I did mean it to be 120, right? And now we've gone through the work of writing that first scenario, right? And so one of the things I wanted to be clear is that, right, we could say, add two numbers, and maybe we want some, maybe this scenario is 50 and 70. Now we want to say, in the next scenario is it was 0 and a number. Right, and then we can say given, and now what we see when I start typing is I've got some syntax highlighting here. Given the first number is, oh, that's the one I want. Yeah, well, let's go ahead and I'll hit tab, and I can just drop my number in here. Given the first number is 0, and the second number is, I can hit tab again. The second number is 10. When the two numbers are added, I can hit tab. Then the result should be 10. Right, and I'll go ahead and watch, and now I've got another test passing, right? And now certainly your test won't necessarily take this amount of time to run, right? The amount of code I'm running and executing with these tests is very small. I'm not opening a browser window in this case and navigating to a page, which would take much longer. But what I wanted to make clear there is that we were able to create a second scenario much faster than we were able to create our first scenario, because we have the nomenclature down, we have the ability to specify these scenarios down, and we've started to get some of these bindings and these steps written up. And as we have those binding steps written up, that can accelerate the actual test coverage that we're able to give our application and the amount of examples we're able to write. So that's our first scenario there with some binding. You know, as I mentioned, in our steps file here, I really, this is a contrived example. I probably would have the idea of a calculator class, right? And if this was a C# class, I would go through the, the effort of writing a calculator and creating an add method that takes in a, number 1 and a int number 2, and then, returns the results. And then this would call that, right? But for the sake of examples, and rather than saying new calculator here, I'm saying, we're going to go ahead and just do that right in our test example. Let's go on to another demo that shows off some of the other functionality around SpecFlow. So in this case, I've got the idea of listing products from, we'll assume some kind of a vending machine. So we can also, SpecFlow, or rather specification by example and the Gherkin syntax, also allow for the idea of things like tables and parameterized examples. So I can, for example, if I want to have, if I have a list products feature, say, as a vending machine administrator, I want to understand the products in my machine so that I'm not clueless. Of course, a very contrived value statement there. But if I have a scenario here for product count, I could say, given I have the following products, and then I can define a table here that has a name header and a cost header. And you see we get syntax highlighting here for the table. We can see the items there. Given I have the following products, I'm at the vending machine with the products. When I get the product count should be 2. Right now, of course, no one's going to stand in front of a vending machine and get the product count. So it's a super contrived example. But let's look at how this is mapped in SpecFlow. Right now, if I hit F12, which I'm going to do now, it's going to take me to where this statement, given I have the following products, is defined. So that's going to be in my list product steps class here. And so we see, given I have the following products, and it can actually take in a table class. And then it has the ability to create an object called product from that table of stuff that's taken in. I've defined this object called product. I've given it 2 properties, name and price. And I can now work with that in my code. This is really helpful if you have production code or production objects that need to get created from a table of values. SpecFlow has a lot of nice features to be able to map this idea of a table of text with headings, to a product object. So now I've got this idea of, okay, I've got products here in my behind the scenes testing code. Given and it says, given, and I am at the vending machine with the products. So given I am at the vending machine with the products, in this case, we're translating that to say, okay, create a new vending machine object and pass in the list of products. So we're testing our vending machine object in this case, and we're going to create a new instance of that vending machine, and we're going to pass in whatever our current products are. So this is, yes, contrived, but the idea here is that someone's going to be wiring up code or production code or doing something with your production code. When I get the product count, we can see it's calling the vending machine, which I've abbreviated to VM here, which I shouldn't. In fact, I'm going to rename that real quick because it's going to bug me. Abbreviations in code, let's be more explicit. Vending machine. All right, so vending machine called get product count. So we're retrieving the count of products from our vending machine object, and we're storing that in a variable here for our test. Then the product count should be 2. So we see then the product count should be, and we assert that that product count variable that we pulled out of our vending machine is equal to the amount that we've specified. So this is an example getting a little more advanced with a table of fields and using an actual vending machine object, that we've created. That's our actual production code that we're instantiating behind the scenes and doing some things with. Similarly, if we have that vending machine here, we may have the idea of buying a product. Let's see how contrived I made this example. This example is a little older. So let's see. As a hungry customer, I want to receive a product so that I can experience a yummy treat, right? Again, that's some value. Sure, let's call that some value. So given I'm at the vending machine, when I insert a quarter, luckily in this vending machine, looks like snacks cost 50 cents. When I insert a quarter and I insert a quarter, now we could have said when I insert 50 cents, but the action here is inserting of a quarter or a coin. And I purchase a product, then I should receive the product. So this is sort of implicit that the vending machine here is charging you 50 cents for any product. But let's look at what we've got here. So given I'm at the vending machine, I'm creating a new vending machine here. I'm not passing in a list of products. It's just going to have a default list of products in this case for the production code. Apologies. When I insert a quarter, I'll hit F12 to go to that definition. It adds 25 cents to the vending machine in that case when I insert a quarter. And this is, say you disagreed about the value of a quarter, or some users wanted to say quarter, some wanted to say 25 cents. Now you've got the ability to you've sort of agreed on what that step is there. When I insert a quarter, so it adds 25 cents, and I insert a quarter, which calls the same exact code to add 25 cents. And I purchase a product, which sets our local variable here in our test to the result of vending machine.purchase product. Then I should receive the product, which in C# terms, we're just saying, hey, make sure we got something back and not a null value. Is how we contrived that example. So our production code here, our vending machine, this is our production code here, right? It has some internal state that it manages with its products. And all of that you can see from these green dots is being exercised at this point by all of those features. We actually are missing one more line, which is that if we don't, you can see this test coverage here, if we didn't insert 50 cents and we purchase a product, it should be null. So let's actually go ahead and write that out. Let's go ahead and go to our buy product feature. Scenario will be called, I guess we'll call it scenario 2, not enough payment, not enough change, we'll call it here. So we'll still have given I am at the vending machine, when I insert a quarter, right? We could also say when I don't insert a quarter and map it to a method that does nothing. In this case, we'll only insert 25 cents. I insert a quarter and I purchase a product. We'll say then I should not receive a product, Okay, so this is a new example. A user has come to us with a new example. We see it fails because we actually haven't created this part of the test yet. I'll go ahead and copy that. I'll move over to my buy product steps and I'll kind of paste it at the end here. Then I should not receive a product. So rather than asserting that the product is not null, we will assert that the product is null. And with that, we should see the test runs and it passes. And now we have the rest of this code path is actually covered. And so what I wanted to demonstrate here mostly is the idea of that we can use this mapping and we can add those additional scenarios. We can see the test coverage, and SpecFlow is giving us that highlighting and mapping to our production code. Now, folks inevitably with this kind of technology or with this kind of framework say, well, okay, well, what about driving a web browser, right? How would that work? How would that work in this case? And while I mentioned I'm not going to do all of the setup code, let's think about how that would work in a web browser scenario. So let's see, when I receive let's think about if this was a web page, given I'm at the vending machine, right? So given I'm at the vending machine, we could probably update this to say, to do, direct browser to vending machine page. When I insert a quarter, to do direct the browser to click the insert coin button, right? Maybe something like that. And I, insert a quarter, right? We've already got that step again to click the button. And I purchase a product, maybe we say to do click the purchase product button. Tell browser to click the purchase product button and to do capture the value of the product label. Maybe there's a label on the screen for a product, right? And then the assertion would be something like, to do assert that the label we captured equals success or something like that, right? And so this is one way of saying that you could map this to some test code that drives a browser. And this is where the separation between something like SpecFlow and something like Selenium comes into play, which is that Selenium is a tool, a fantastic tool for browser automation. But you could write very confusing tests with Selenium, and you can write tests that don't necessarily map to features with Selenium. And so what I recommend is the idea of using Selenium here, but making sure that you have this specification by example that's really driving your features and your understanding of what's happening in those examples. And so you could easily insert, well, not necessarily easily, there's still some setup code involved and a little bit of effort and some elbow grease involved, but you can bring something like Selenium or a web browser driver into this this testing mechanism in a fairly straightforward way. And with a little bit of setup to open a browser window and building up the steps and the actions over time, you can get to a pretty healthy automation environment that is using web browsers to drive things as well. And I do have an example of it's doing some basic web browser driving, so I'm happy to share that with the group if you're interested afterwards. But I did want to mention that's sort of how we might insert that into the workflow. The last thing that I wanted to show tonight in terms of this demo of SpecFlow is that I'm using SpecFlow, the tool here, but there's actually SpecFlow is a company. It's a company that's giving these tools for free as part of another organization, but there's a suite of tools called SpecFlow Plus. And what I've actually done is I've installed one of these tools called SpecFlow Plus Living Doc. So one of the challenges we sometimes have in these environments is saying, okay, well, I've got these specifications, that's great. They live in my code base. That's great. You know who doesn't have access to our code base? Our business stakeholders, right? They're not hanging out in Git and GitHub. They're not always. It's great if they are. It's fantastic if they are. But they're oftentimes at arm's length from this stuff. How do we actually show them these scenarios and that they're running and that they're working and let them see what the examples are that we have? And this was key to our success with our 3,500 tests previously. So if I go, I'm going to open a command prompt here briefly, and I'm going to go. See here. Sure, let's open a command prompt window. I'm going to drag it over from my other screen here. And I'm going to go ahead and actually, I'm going to open a command prompt window from in my presentation directory here. So I'm going to go to the place where these are in my code base here. Joy of functional code. Let's see here. I think let's look at the other demos here. I think I can actually run here, living doc. I'm going to run this command here on my screen, which is living doc is what I'm calling. I'm saying I want to use the feature folder methodology, and I want to start from where I am, which is in this folder with all of my stuff. So let's see if I can go ahead and spit out an HTML file here. We can see if I run that, livingdoc.html was successfully generated. So let's go ahead and look at what that is going to look like. I'm going to open that file over here. One moment, I'll drag it over to my screen. So here we actually have a generated UI that anybody can look at. You can publish this along with every revision to your code if you want. You can also hook it into your automated test system and what tests have passed or failed, so that business users or any stakeholder doesn't have access to the specifications can still look at exactly what these specifications are with some decent UI. So I can look at the product count feature that we have here. I can see the exact piece of value that we're trying to get to with these scenarios. I can look at the scenarios. It has nice formatting on the table, nice formatting on the given and then when then steps. And if this was a generated document that I had tied up to my test results file, I can see very quickly what's passing, what's failing, what steps they have run, what feature titles they have. And so this is a great way for folks to, this would be filled out with analytics if I hooked it up to our test statistics. So this is a great way for folks who aren't directly operating with the code base to have visibility from your build system or your deployment system into exactly how many of these specifications there are and how many are passing or failing. So it's a great step of transparency and building that trust and confidence. And one of my favorite parts of when we implemented this on my prior project was that we found that stakeholders were going to this page actually way more often than we thought they were. And they were searching for features and they were suggesting examples based on what they saw missing. And that was a phenomenal moment for us because we had this great feedback loop, and it was great for them that they would then see an automated test with exactly the examples that they cared about start to show up here in this list of passing tests. It did a lot to build confidence. And of course, a key component of that was collaborating the folks who were writing the code with the QA folks, who in some cases wrote some of this code, in some cases made sure to double check the code that the automation was doing what everyone thought it should be doing. So it became this great collaborative process, but it was driven by this feedback loop that folks could start looking at. So many tools such as, there are various tools in the Java, .NET, Python, Ruby ecosystems that will do similar things, but I wanted to call this out as an example of the kind of tooling that I think we should be aspiring to with our integration, and to make sure that our users are seeing an example of it. So that's what I had for this evening. And so I know I've talked a lot so far, but I wanted to open it up for a few questions, and also happy to dig into some examples, as long as they're not going to get into too much complex code for this audience. But with that said, feel free to fire away with some questions or any comments that you have.
So I was gonna say, you can feel free to add it to the chat in case you're unable to unmute yourself. But if you're able to unmute yourself, please feel free to ask Sean any questions you may have.
Absolutely. And certainly I'm happy to hang around for a little bit for some questions as well. So we'll look to see if any come in the chat. But I do want to say, thank you for the opportunity. And I do think that this functional testing and meeting your users where they are and beginning this collaborative exercise of using examples to define your scenarios and building that feedback loop in, so that users who are removed from the code can still see the examples and the value that the system is providing and building up over time. I think you have the opportunity to add a great deal of value. And as QA professionals and automated testers and folks who care about automation, you're so central to the trajectory of a team like this, because you can introduce these practices, you can introduce them slowly over time, you can work with your developers, you can learn the coding behind the automated test systems, even if you're not a coder and you need a coder to build you some of the basic steps that you can then build upon. There's a lot that you can do here to get started with automation and in moving your teams forward in a safe way and moving quickly.
Hey, Sean, this is Peter. I had a question for you.
Sure.
Yeah, I think a lot of us, first, great job. Thanks for sharing.
Sure.
Yeah, when you're talking about Gherkin files, one of the things I was curious about is, I almost want to say as a developer that all your test cases failed. And the reason is, why is it in the quality engineering space, in the Gherkin file, quality engineers use the word should instead of shall or must? Because doesn't the word should kind of mean implicitly it's optional? Like, I would never work on a government contract for NASA and see the word should do this or should do that. And it's just really weird that in the quality engineering space, testers who are supposed to say, 0 or a 1, they use the word, ambiguous words like should instead of must or shall. Any comments on that?
Sure. Well, I would say that I tend to see them as identical myself, in that when I see something should do something, I am assuming at that point that is being exercised. And normally there's, for example, a great library in .NET called fluent assertions. And so I could say assert that, the amount of change is equal to 25, right? So that's an assertion. That's some pretty strong language. Fluent assertions lets me say, change.should.be 25, right?
Now I'm familiar with that. I do a lot of Node, but I'm just saying, I use Gherkin as well, and I use the word should, even though it drives me crazy, because I mean, if you look it up in the dictionary, it's just an optional word. It doesn't mean it has to happen. That's all.
Yeah, to me, I don't get so caught up on the phrasing in that terms, as long as we're all on the same page about what it means. And when I see that
I think it's
in an
about
automated
the
test,
like,
you
if
have
your
to
product management, if your product management's okay with the word should, then I think it's acceptable. But I've been in workplaces where the word should, especially with developers, right? Because they're part of the Migos, they really have a disdain for that word for our test cases, our Gherkin. So I was just curious how you thought.
I personally, it doesn't bother me so much. I would love to see, actually fluent assertions might even have this, I haven't checked, but the idea of, saying dot instead of, change dot should be 25, change dot must be 25. And that's fine as well. I think the key thing that I care about is that's an assertion that's being executed and something will fail if it's not the case. And so whether we use the word should or not, I think that in this case, we're saying something should be this way. It's possible that it won't be this way, but if it isn't the way that we expect, the test will fail. And so I think the end result ends up being roughly the same. So it doesn't bother me so much.
I think I actually know the answer to that question. I think it's historical.
I agree.
The first version of that predated SpecFlow was Cucumber, and that was written for Ruby.
Correct.
And Ruby at the time, the most commonly used unit test tool that went with it was RSpec. And RSpec used the word should.
That's right.
They have since changed that to expect. But I guess that the reason that it's still hanging around in should in a lot of places is just because people got in the habit of using should.
Absolutely true. And there's no reason that we couldn't switch that. I should receive the product. You can say then I receive the product or I must receive the product. Absolutely. But you're right. I think it's that the distinction gets lost on a lot of people, including myself, I guess. I really don't see much of a distinction there, but I can understand certainly in a high pressure environment that you are a mission critical environment such as NASA, that you're not going to want to see should in your code. And in that case, I would say it's doing the same thing. Let's just write an overload called must that calls the should phrase, and then we're done, right? Or let's change the wording then, and the same result of executing that test and asserting that is going to happen.
I have a question for you, which is, so the tool you were showing us, I hadn't seen before, a living doc.
Yes, this is SpecFlow. It's a part of the SpecFlow suite of tools.
Well, what are versions of that for other versions, of Cucumber in Ruby or Java or Python?
Sure. There's one tool I know of in particular called Pickles that will take Gherkin formatted feature files. And you got to love the puns, by the way. If we haven't gone into the puns, right? Cucumber, Gherkin Syntax, a tool called Pickles, right? There's clearly some programmers love a good fun naming challenge. So Pickles is a tool that can point to a .feature file that's in Gherkin format and generate HTML for you, similar to what I showed. And that again that's a free tool as well. And so you can certainly use the SpecFlow living doc with a feature file. And I think there's another one in Cucumber land that I'm forgetting. So you'll forgive me. I'm literally Googling Cucumber Gherkin test page documentation or test generation, results generation. There is a tool, and I think Cucumber itself may have reporting tooling as part of it as well.
Yeah.
I do see there's a Cucumber reports service that contains information about what scenarios have passed or failed, but I don't know if that's in a searchable nice UI or whether that's going to provide that experience. But Cucumber itself, I believe, has the reporting feature. I just don't know if it has that nice searchable UI. There are also several, for example, various IDEs and test runners. If you happen to be in the development space or you're working in your development tooling, there are a number of plugins for whether that be Eclipse or Visual Studio, if you happen to be working with that tooling, that will also help show some of these results. So most of my, so the test runners that I have a few plugins for my tooling. One is called ReSharper, another is called that mCrunch tool that you saw. If I was to run those tests and expand those, SpecFlow has generated the names for the tests that are still going to help guide me to what's going on there.
I just like the fact that there was something that we could share with the business folks.
I'm having trouble hearing you.
Get into the IDE.
Let me see. I may need to move my headphones here. Sorry about that. Can you try again? Can you try speaking one more time?
Oh, I'm sorry.
There we go. My headphones have come out, so I apologize.
I just liked the fact that there was something that made it easy for the business folks
yes.
to see what was going on, as opposed to asking the developers to just run them and then look at it.
Right. And the ability, I think the key for me is the ability to search those examples, because I think what oftentimes, rather than saying, oh, here's the result, when we actually show the examples and allow those stakeholders to explore the space a little bit, what we found is that we got back a lot more quality examples, because in this exploration, in their own space, in their own time, they were able to kind of look at the examples we had and suggest others. And I think that providing that ability for someone to explore on their own rather than depend on another team member really helps bring them into the collaborative process. And certainly that was what we saw in the example I provided, where those business stakeholders got much more actively involved, I think, just as a result of having that at their fingertips in their own space and time.
If you were going to try and describe the types of organizations or types of problems that you think SpecFlow is right for solving, and then types that maybe it's not necessarily right for solving, but people might misunderstand what it is, like based on the presentation, it kind of sounds like something that is great for like organizing and annotating test cases, but not necessarily the content of it. Like if your test suite is a book, SpecFlow is like the index, but not the pages with the content.
I think that, so the way I would see it is that and part of that is that this is an hour-long presentation that I wish I could talk about for 3 days, because there's SpecFlow is a certain kind of automated testing. And what we're really saying is that SpecFlow is and specification by example are really well suited for tests that need to kind of be outside looking in at what your product is doing, where you really want to describe in human understandable terms, rather than relying on developers to write automated tests at a lower level that humans can't really read unless they have a coding background. So what I will say is I think it's very broadly applicable to any software that needs to communicate about what it does, which I would argue is most, if not all, types of software. The level at which we communicate there is going to depend on the business stakeholders. If you are a startup team and every stakeholder is really well versed in the code, or you're an entire team and the entire team has a background in coding, then maybe, just maybe, you might skip those tests. However, I would still argue that I would want those tests written that way for when the team expands, or when we need to communicate that outwardly, or when someone misses a piece of code and what it does and doesn't quite understand it. Having those human readable examples still ends up being key for the collaboration of team members. And so I think it's really broadly applicable. The piece that's the index, I would argue, is that last piece that we generated, right? The SpecFlow says, hey, I'm going to tell you the plot that should happen, right? And it says, hey, turn to page this now, turn the page, this page, then this page, and then assert that we've kind of got the points of the plot. But the living index, just to keep it in metaphor, the living index piece is that living document that I showed at the very end that says, here are all the examples that we have come up with. And here are those examples and the results of those examples that are being executed, right? The key is that those examples are living things that are being executed against your production code. And so I'm not sure that answers your question, but I do think that SpecFlow and functional testing at that level, using that Gherkin syntax, is broadly applicable in almost every kind of software that I can conceive of.
Do you mind if I add something? I'm sorry, do you mind if I add something to what Sean just said? I think it's very important to note that he did show a diagram of what the other sort of testing strategies you should still employ. I kind of have a love-hate relationship actually a little bit with functional testing. I do enjoy it for all the reasons that Sean has presented, but there are downsides, right? There's always a downside and always a cost to everything.
Absolutely.
I would say if you are looking to embrace this particular strategy for your entire testing ecosystem, just make sure you do it with caution, make sure it has a place, make sure it has the value and the impact you want. This should not be a replacement for any unit tests. I've seen, that kind of, everyone gets really excited because they like the colors and then they don't write unit tests, and we all know that's very, very bad.
That's a great point. And in fact, for those of you who haven't seen it before, there's a testing pyramid diagram, or it's sometimes called the testing funnel, and it's inverted. Now, it's I'm Googling the image here, so this may not be the one that I would specifically go to right off the bat. But when we think about various levels of tests here, typically what we tend to prescribe in the classic methodology is we say, okay, you should have the most unit tests because unit tests are going to verify the correctness at a very micro level. However, and then you should have integration tests where maybe one or two components are operating together. And from there, maybe you have system tests that are putting together many components to try to achieve that. And now you're getting into functional tests. And now you switched from talking about, hey, I'm a developer and I'm saying this component or set of components works a certain way, to functional tests, which was saying I as a business or an end stakeholder might expect the system to work this way. But what's important to note is that oftentimes, if you are a tester and you have no background in coding, these first three layers do not seem accessible to you. And so you instead are going to embrace the idea of maybe UI-based tests or functional tests. But as Cynthia said, there's a reason why we may want to do these tests more sparingly. And just to be brief, those reasons are that tests at these higher levels are more brittle and prone to failure because they're orchestrating many pieces of components. As I mentioned before, functional tests require, you can't really have any fake components. So that means you've got to actually have a database, or if you're using a database, you've got to actually have a network if you're using a network. At least I should say that typically speaking, you can in some cases fake some of those components out. But the idea there is that, okay, so if the network is slow, or if you're working with files on a disk and you hit a permission error that has nothing to do with your software or the correctness of your software, those tests will still fail. And you will have to troubleshoot them and maintain them accordingly. Similarly, if any of the components change at the unit or integration or system test level, you could still see a failure at the functional test level, right? So those tests tend to break a little bit more often. Because they're using typically real components together, they also tend to run a little bit slower, in some cases a lot slower. I know the one project I was on had 26,000 unit tests and it ran in about 2 minutes. And they had 200 UI-based tests and they took 3 hours. Right. And so there's a real cost there in terms of the trade-offs. What I typically recommend to folks is, hey, if you don't have any tests at all, right, then maybe starting with UI-based tests that really test the system from the outside in and do some of that browser-based testing might be great to help you cover some of your basic paths through the system as you work to build up test coverage at these other levels. My goal would then be to build up test coverage at those lower levels such that we can remove some of those top-level UI tests because they're a little bit redundant now or they're not providing as much value. So there's definitely a consideration there, and there are different takes on that, right? And I'm sure based on the day, I might feel slightly different about what I just said. But typically speaking, the idea is there that we want to approach those tests that require real components with a little bit of more of a degree of caution. And so it's true, Cynthia mentioned that folks get into the idea of browser testing or the ability to drive those things from the outside in, and that starts to be the only testing strategy that the development group considers. And that is definitely a pitfall that you want to avoid. What happens in that case is you wind up with a very brittle test suite that becomes very difficult to maintain over time. It breaks, it takes forever to run, so your feedback loops are much longer. And what happens is that rather than confidence in your system going up, confidence in your system decreases, and the maintenance burden of your tests increases at the same time. So all of a sudden, the value proposition of automated testing is like, well, why are we doing that in the first place? You start to comment out tests. You start to run your test less often. The tests decay. It becomes a downward spiral in terms of maintenance, right? And so what we want to do is we want to keep those feedback loops small, or at least as small as possible in our current context, and be aware that many UI tests are going to increase that burden. So I think, Cynthia, you're spot on there, absolutely.
I also didn't want that last statement that Sean said to be a deterrent for everyone to try this. Like, there is value in making sure you even have these first discussions, right? Like, Gherkin itself can be very valuable even if you don't want to use SpecFlow. Like, it's a very great first step to make sure, Peter pointed out a very good point as well that I've had in the past with Gherkin. Like, even things as small as words have very powerful meaning. So I might interpret a word very differently from someone else, and that helps open that dialogue to make sure assumptions don't creep in and actually make problems, right? We all know through our many years of experience that it comes down to misconceptions and assumptions that really make big problems for us. So the sooner we can get those out and make sure we all have the same context, the better we are just in the long run.
Absolutely. It helps make those implicit ideas and those implicit different thoughts explicit and put them on the page for everyone to collaborate on. I think that's totally right.
Actually, I think the guy, who was it, John, or whoever asked the original question, John, did I answer your question? Because I think from what I understood from your question, it was not so much about Gherkin. It was more like, is it worth it for you or your team or similar team to even use this? Because from my understanding, you want to use Gherkin or some kind of BDD format. And I think you were insinuating, why do I want to write a bunch of tests, cases, or use Gherkin when I know the time and effort to automate this later is going to require so much more effort? And I was going to...
Yeah, it was kind of like that. I mashed probably 3 questions into one.
Yeah, that's what I thought. So let me answer for you.
I think the thing is basically like, you know, if you were a doctor and prescribing this to a QA team that needs this bad metaphor just died midway through, but like, you know, what are the kinds of problems that this solves? Because it's not a cure-all, and there's some teams who'd be like, they'd probably go and say like, actually, maybe you need to look into something else because this doesn't sound like it's for you.
Right.
Sure.
So this is what I can share with you, because I was on your side, right? As a developer background, I thought it was all, pretty stuff, but this is what I learned in the past couple of years using a BDD strategy or a process. It's when you're using Gherkin, I kind of feel like since you're using a very tight formal syntax with a given when then, and when you get a new feature, you can write test cases real easily with the given when then. It's a really easy to use DSL, domain specific language. So right away, the cool thing about it is you can write your test cases, your scenarios, make it data driven. And so now you get your feature. You can use your handwritten Gherkin, your test cases, and do manual testing. And so now once you have the application in your hands, the cool thing is you can use a BDD or a behave test framework like SpecFlow, and now you can start automating against the Gherkin files that you have. So in other words, you're not wasting time because your feature files, they get converted into your automated tests. And so that's the buy-in for me.
Yeah, I think that's a fair point. I think that, and granted, if you were converting all of those feature files, there certainly is some effort involved there, but switching to the Gherkin syntax does provide still many of the benefits of specification by example, right? So in terms of the clarity of language, the consensus that it forms around the requirements, the ability to have someone, whether it's a QA person or a business stakeholder, follow the same set of steps to verify something, and the ability to sort of create that modern test script, and also see if there are features that are conflicting. I mean, you're still going to get all that benefit just by switching to using the language. But it's true that does tee you up in this case for automation and for converting some of those feature files. But I think that the importance there is that you be considering the clarity of the language and making the implicit ideas explicit, and making sure that it's sort of bringing that to the forefront earlier on in the process. To me, that's the biggest benefit, almost even more than the automation, because it's those conversations earlier on in the process that get us on the same page for delivery. Certainly, I think the automation is a key part as well, but the collaboration and the consensus around what is this thing actually supposed to do, and how are we as a group agreed that we should verify this feature, this functionality. Those points of clarity end up being really advantageous.
So hypothetically, even a purely manual organization would get some benefit even just by writing their stuff in that format.
I would say yes.
Yeah.
I would
make your examples concrete though. The thing about writing them as though you were going to write an actual automated test means that you have to have exact data. And
yes.
if you write them in such a fashion that you're only writing them from I just want to make some notes here point of view, then they can be vague. And if they're vague, they can be ambiguous. If they're concrete, they can't. I've found wonderful conversations with the the product folks and the developers together when working together on user stories. Also, you have a bunch of these. It's a really good way to slice a story by test criteria.
Absolutely. Yep, that's key. And in the workshop that I used to run for QA folks, we spent a couple hours going through and revising this sort of syntax. But that is absolutely key, that you can one of the reasons I said earlier on that the given statement sets up sort of the universe of the test is oftentimes when folks write a test, they'll start to say, okay, well, when I click on Sean's profile, right? And you say, okay, well, what has to be true in order for you to be able to click on Sean's profile? Or there's got to be a profile that exists in our database somewhere associated with Sean, right? And so that sort of starts to feed itself into the given criteria. And then you can start to use that in the setup of your tests. And we didn't get to talk about that too much tonight, but that starts to really help factor into the efficiency of your tests and the efficiency of doing things like generating databases with test information or generating information in a lean way that's going to inform your test, rather than, say, taking an entire production copy of your database and using that in a test environment, right? Being able to define what data the test needs or what the universe of the test needs helps you write leaner, cleaner tests that are going to run faster as well.
Hey, Sean, did you use other tools other than SpecFlow? Like, did you use Python's PyTest or any of the other Behave frameworks?
That's a good question. So I've used them sparingly. Most of my work is in the .NET ecosystem. Typically speaking, I would suggest that you would match your sort of tooling stack in this case, given that this is a kind of a collaborative effort between folks who are coders and folks who are maybe writing less code. One of the things I would suggest doing is sticking with the kind of stack of tooling that is in the same language of the production code that you're writing, where possible. You certainly don't have to. I have seen instances, for example, where applications are written in C# and it's a web application, and the QA folks know how to code, they're writing code, but they only know Java, they don't know C#. So the test suite is written in Java. That can be okay. It can sometimes cause confusion and inhibit collaboration because you're literally working with two different languages. But as long as you are collaborating on those feature files, I think you're good. One of the things I would suggest, though, is I wouldn't start off that way if I don't have to. So since my work is in .NET, I'm looking for tooling and that ecosystem also in C#. And that is so that I can also get some efficiencies out of that. So if I'm running a web browser, that's one thing. But if my tests are in C#, perhaps I can call code slightly below that level, right? And I can do that by instantiating an object in C# that I wouldn't have access to if I was writing these tests in a Java environment. And that can help us get lower on that testing pyramid than just doing everything at the UI level. When you're operating at in those different languages, you're kind of stuck with the lowest common denominator, which tends to be the UI in a lot of cases. And so, just to avoid some of those pitfalls, and sort of Cynthia mentioned, unless it's required just because of team skills or the state of the art of your current team, I would recommend trying to adapt a stack that is alongside the same tooling that you're using for your production code.
Cool, thanks. Oh, one last question. Does SpecFlow run in parallel concurrently?
Yes. So SpecFlow runs in parallel. They had a small bug that they just fixed actually that lets it run much faster in parallel. But the caveat there is that SpecFlow runs in parallel, which is fine as long as your production code can also run in parallel. For example, in the .NET world, for folks who are doing multi-threaded code, there's potential for locking, or if your code is in what we call thread-safe code, then executing tests in parallel is fine. But if your tests themselves use state in your code, that state can get garbled, leading to strange test results or tests failing when they shouldn't, and so forth. And so, depending on the technology stack that you're using, there are some things to be aware of there. Also might be limiting by the idea of, if I'm running tests in parallel and those tests open up a web browser, I may not want to open 300 web browsers at a time on my test machine, right? Typically, If you have the appropriate isolation of your data and the pathways and you have a powerful enough machine, yes, you can parallelize it. So that is to say, yes, this tooling supports parallel text execution. It tends to be parallel by default, but it's only going to be as parallel as the rest of your process and production code allows it to be. So if you have tests that the code can run in parallel very easily, but it shares the same data because you're using the same example data, and maybe you shouldn't be, then that data being saved back and forth in the database might be problematic. If you're in the .NET space and you're working with a database, one of the things we typically do is we'll use transactions in our tests. So we'll set up a database, we'll open a new transaction in each individual test that is running in parallel. We'll make the changes to the database within the space of that transaction. And then rather than committing that change to the database, we'll just throw it away at the end. And so that'll allow us to kind of set up our test data, run a bunch of things in parallel rather than having to wait for the actual commits to the database or having tests kind of get crossed wires with the data they're using. So there are a number of considerations, but SpecFlow as a library is built to allow the parallel execution of test code. Yes.
Sean, with your demo, you're doing it all in the context of Visual Studio, which is cool to do it during dev time. But then what does that actually look like in practice if you were to deploy it to like a CD pipeline? I'm thinking Azure DevOps. And if this is more than you want to get into, kind of can you give a 10,000 foot view of what that looks like?
Absolutely. And so I think the key thing to remember about SpecFlow is that behind the scenes, SpecFlow is generating NUnit tests, right? So it is just generating NUnit framework tests behind the scenes. So NUnit being a standard unit testing framework in the .NET space. So I added the SpecFlow package to my project, and then I added SpecFlow.NUnit, which says to SpecFlow, hey, use the NUnit flavor of tests when you generate your tests behind the scenes. So when we get into a build pipeline or a continuous integration and delivery pipeline, I can execute those tests just like I would execute any NUnit test. Right, and we can see the results similarly to how I'm executing those tests. SpecFlow happens to have its own runner as well if you happen to want to put a certain lens on it. But for the purpose of a build server or things like that, we run those tests the same way we run other NUnit tests. Now, if you're using browser stuff, right, you may have to do some additional setup in your pipeline, right, and all that sort of stuff. But the idea there is that you should be executing those tests just like you would execute your unit tests and your integration tests by running the NUnit runner and pointing to those tests. SpecFlow is kind of really nice tooling and syntax on top to map that stuff for human consumption.
Is there a build step or something that takes the feature files and transpiles them, so to speak, into?
At the risk of getting too far into it, I'll show you exactly what's happening here. So everyone else prepare to see a bunch of code that you might not care about. So in this, so for example, the buy product.feature, when I hit save, right, or when I build the project or whenever I save the file, you'll notice there's actually a code behind that is happening here. Behind the feature file, it's actually generating a C# file. It's going to look super garbled, but I'm going to go into it. It's auto-generated. You should never touch it. But what it does is you'll see here, it's calling the generated code attribute. It is creating an NUnit one-time setup attribute behind the scenes. It is creating an NUnit one-time teardown attribute, and these are terms that you're going to be using in NUnit specifically. So it's using the NUnit library behind the scenes as if it's writing automated tests. The difference is basically it's generating an automated test that says run these steps in this order and then make an assertion. So it is creating a test that says call this receive a product step, and then call the IM at the vending machine step, and then call the insert a quarter step, and then make an assertion. So we're sort of using SpecFlow to drive our unit testing library behind the scenes, our automated testing library. But the nice result of that is that at the end of the process, this hidden file here actually is a collection of NUnit tests that your build server or other pipeline can run.
Gotcha. Cool.
Did I answer your question?
Yeah, that's great.
I think we have one more. I have time for one more question. Before I think everyone has to go and tend home duties now. Thank you for everyone for staying on for so late to and also asking really great questions to Sean.
Yeah, the questions have been fantastic. It's been really nice. Thank you.
Sean, if you've got any like resources for getting started, I know we have at least one QA analyst on my team who is SpecFlow curious, and she mentioned today when I was on a call with her that she just ran into a brick wall that she couldn't get past. If you could maybe share those on the meeting, if you've got some links or something like that.
Absolutely. One of the great things about SpecFlow recently, if you're talking about SpecFlow in particular, is SpecFlow, the team, was acquired by a company that is making a gigantic investment in SpecFlow. And so because the company itself is using SpecFlow on a daily basis to drive its product. It's Tricentis is the name of the parent company that acquired them. But the fantastic thing about that is that there's a number of great resources now for getting started with SpecFlow. They've revamped their documentation. They've added tutorials. There's a Twitch channel where people are walking through examples live. So there's some YouTube videos as well. And so that's only going to continue to get better. They're also building a community of folks like me who've used the tool before, who maybe want to write an article here or there, or give a talk here and there. And while I do this independently, SpecFlow certainly is like, hey, you're doing that, that's great, right? And they encourage the community to do those sort of things. So the other thing is that all of the code is open source. So if anybody's solving a bug or wants to get involved or wants to improve an aspect of the tooling, they're taking their open source nature very seriously. They're pretty collaborative as a team. So I would say the SpecFlow website and documentation has some tutorials. They also have been doing a lot of guest posts on their blog. Gojko Adzik, one of those key figures in the specification by example movement, actually has done a whole series of blog post there on Gherkin syntax and cleaning it up, and how would you write Gherkin in these certain scenarios. And so there's a certain article series, but if you go to the SpecFlow blog, you'll see those posts. And I thought those were really great because they're sort of in the challenge and response format. They'll post a question and then they'll post a number of ways to approach the problem and solve it. And then he kind of gives his take on how he thinks you should approach that. And so I found that to be a great resource as well. So I'll pass some of those along, but starting with the SpecFlow homepage and the documentation tutorials they have is going to take you a lot farther than it used to. And certainly, if anybody gets stuck or is interested in this product, you can always send them my way, right? I'm always happy to talk about this sort of stuff. I've appreciated talking to this group, and I know we're only scratching the surface of what this kind of tooling can do. So if anybody's looking to continue the conversation, my contact information is here, and I'm happy to talk to you anytime about this stuff.
All right, well, thank you very much, Sean. And I don't know if people want to turn on their cameras, but I figure we could give them silent round of applause. Again, if you can't unmute, it's okay. We all understand all our homes are different.
It's a very, very, very nice thank you. I appreciate the opportunity, and then I look forward to coming up with other topics and joining the group as an attendee in the future as well. It's a great group, and thank you very much for having me.
Thank you so much for presenting.